Hey Trig kids, this is chapter 8 review that I'm going to let you guys work on today for a little while. I had a couple kids comment below or contact me saying, would you do this one, would you do this one, would you do this one in your video? So I'm going to go through the ones that were commented on. They are circled on my page, so we're going to go through 7, 11, 13, 14, and then a few of them on the back side. So 16, 17, 18, and then 20A. I might as well do 20B with you probably too. So we'll go through quite a few of these together just to kind of get you on the right track. I am going to allow you to skip through this video, so if there's questions that you don't have, like if you didn't have a question on number 7, you won't have to sit and go through that with it. I would, however, skim through and make sure you have the correct answer when we get the answer at the end. So I will let you skip through this video so you can drag that along, okay? So starting with number 7, they don't want you to use your calculator, they want you to find the exact value. And what's going to happen there, let me make my screen bigger. What's going to happen there when they say find the exact value is they want you to use the unit circle, okay? So that's all they want you to do. Now, if this question were presented as this instead, tangent of theta equals negative square root of 3, okay? This would be saying find the angle where tangent is negative square root of 3. Okay? So what we want to do is look on our unit circle and find the negative square root of 3 for tangent, and there are 2 places, and the first one of them is at 2 pi over 3. Okay, so I have 2 pi over 3 is going to be one of my answers. Okay, and negative pi over 3, or negative square root of 3 is also at 5 pi over 3. Okay, now here's the kicker though. Be careful of this. 2 pi over 3 and 5 pi over 3. That is if they would have asked the question like this. They're saying tangent of what angle gives me negative square root of 3. Okay, but they are asking for inverse tangent of that guy. And so we're in the domain of inverse tangent. We're looking at his domain instead. Okay, not the domain of regular tangent. Domain of inverse tangent. And inverse tangent will only exist in that first and second quadrant. Okay, I don't have that written on my unit circle here, but inverse sine is here and here. No, wrong. Inverse sine is first and fourth. Inverse cosine is first and second. Inverse tangent is first and fourth. Tangent. Okay, so we're going to write it like that, and we're going to figure out which one of those angles, 2 pi over 3 or 5 pi over 3, are in the domain of inverse tangent. Well, 5 pi over 3 is the one that we want to use and not 2 pi over 3, except they will write 5 pi over 3 as negative pi over 3, right? This was negative pi over 3, this was negative pi over 4, and this was negative pi over 6. Okay, so they will probably write that as negative pi over 3 instead, okay? Probably on the test, I'm not going to get terribly picky. If you give me 5 pi over 3, I'll probably say that that's maybe okay, but make me happy and do negative pi over 3 instead, okay? All right, so that was number 7. Number 11, find the exact value without using a calculator. So we're going to look at the inside first. We always look at the stuff in parentheses first, and they're saying find sine of pi over 6. That's what we're doing there, okay? So looking at pi over 6, the sine value is the y-coordinate, and that's going to be 1/2, okay? So y-coordinate 1/2, sine of pi over 6, I can cross that out and put 1/2 in its spot. Sine of pi over 6 just reduces to 1/2, so there he is, okay? Now, similar to what was up above there, I want to find inverse cosine of 1/2, okay? So on the unit circle, where is the cosine value? 1/2, okay? Well, cosine is the x-coordinate. Here is 1/2 at pi over 3, and he's also 1/2 if you go all the way down here to 5 pi over 3, which is negative pi over 3, okay? So I have pi over 3 and negative pi over 3, but which one of those is in the inverse cosine? Well, inverse cosine is only first and second quadrant, so I'm not going to use this bottom one down here. I'm only going to use positive pi over 3. Okay, so I hope that made sense a little bit. That's what you should get, okay? You should only get one of those answers. All right, now, this one, number 13, this, we start from the inside again, and this one says inverse cosine of 5 over 13. We're not using a calculator here, but I don't have any 5 over 13s on my unit circle. I don't have any. What this says right here says that cosine of some angle theta is equal to 5 over 13. That's what this says, but just in a backwards form, right? So I need to figure out what that angle theta looks like, and I'm going to draw out what he looks like on kind of a unit circle, or draw a triangle of him, and that will help me figure out what tangent of that is, okay? Now, I always draw my triangle in the first quadrant, and I think I remember explaining to you before that the first quadrant is the only one where sine, cosine, and tangent all three live, okay? In the first, or in the second and fourth quadrant, only cosine live and only sine and tangent live. The third quadrant, inverse, doesn't live at all. So I'm going to use the first quadrant, and I'm going to draw my triangle in the first quadrant. So angle theta is going to be this guy right here, and I know that his cosine is 5 over 13. That means the adjacent side is 5, and the hypotenuse side is 13. Cosine is adjacent over hypotenuse. So the adjacent side is 5, hypotenuse side is 13. This side right here, if you would do the Pythagorean theorem, or you should probably know this one by now, that should be 12. Okay, that side's going to be 12. Now, this part is done. We've done that part already. And now we just want to figure out what tangent of that angle is. So looking at this, I know what angle theta looks like now because of that inverse cosine. I just want to find tangent of that angle, okay? So tangent is opposite over adjacent, okay? So tangent of, I'm going to replace this with angle theta because this really tells us what angle theta looks like, okay? Is opposite over adjacent, which is 12 over 5. 12 over 5 is going to be what my tangent is, okay? All right, so hopefully that kind of made a little bit of sense. 14 should be probably just a little bit easier for you now then, because it's kind of the same concept. So inverse sine is what I'm going to be working with first. So I'm going to draw my triangle in the first quadrant, okay? Again, I know to do this rather than doing it like number 11 because I don't have a 4/5 on my unit circle, okay? And 4 and 5 is going to make a nice right triangle somehow, some way. So that's how I know that I'm going to be drawing a triangle rather than just looking on the unit circle. So this says sine of some angle theta is equal to 4 over 5. And sine is opposite over hypotenuse. Okay, so the opposite side is going to be 4. The hypotenuse is going to be 5. This bottom side here is going to be 3 because it's a 3, 4, 5 right triangle. Okay. All of them are going to be positives because we're all working in the first quadrant. Okay, and then we have secant. Okay, well, what the heck is secant of that angle theta? Okay, sine, inverse sine of 4/5 told me what angle theta looked like. Okay, so I'm going to kind of replace that with angle theta, and now we're finding secant of that. Okay, so secant goes with cosine. Cosine is adjacent over hypotenuse, so secant is going to be hypotenuse over adjacent. Okay, so we need to figure out hypotenuse adjacent. Hypotenuse is 5, adjacent is 3. 5 over 3, that's what he is. Okay, all right, so draw him out. If you don't have those values on your unit circle, you're probably going to end up drawing a right triangle for it. Okay, all right, going to the back side, number 16. Find the exact solution for cosine of 2x equals the square root of 2 over 2. Now, this is not inverse cosine, so we will have two answers here in this case. Okay, not inverse cosine, we will have two answers. So what we want to do is we want to get rid of cosine here. So we are taking the inverse cosine, but we, since the original problem gave us just cosine, we are in the domain of cosine, which means I'm going to have two values. The domain of inverse cosine, if we are starting with inverse cosine, the domain of that is only going to have that one value because you're only dealing with two quadrants. Okay, so I'm looking at doing inverse cosine, and when I do that, inverse cosine of cosine is going to cross out, so I will just have 2x left on this side. Okay, and then I'm looking for inverse cosine of the square root of 2 over 2. Okay, so there are two places where cosine is the square root of 2 over 2 at. Okay, and we're going to find both of those two places. Okay, so square root of 2 over 2 is right here at pi over 4. So we're looking at the x-coordinate cosine. Square root of 2 over 2 is pi over 4. And it's also going to be at 7 pi over 4. Okay, so pi over 4, 7 pi over 4. All right, so this guy is pi over 4 or 7 pi over 4. Okay, and when I write that out, I can say that 2x is equal to pi over 4. And 2x is equal to 7 pi over 4, okay? Because that's what inverse cosine is. I'll either have one of those two answers, okay? And then to get x by itself, I'm going to divide by 2, okay, for both of these. So pi over 4 divided by 2 is kind of like pi over 4 times 1/2 if I keep flip it. right? So x will be equal to pi over 8. That's what one of, oh shoot, I need to put plus 2 pi n on the end there. Okay, plus 2 pi n. Why 2 pi n? Because the cosine's period is 2 pi, okay? This guy is going to be, if I take 7 pi over 4 times 1/2, that will be 7 pi over 8 plus 2 pi n. Okay, and that's what he will look like. So those are going to be my 2 answers for that one. Okay. All right. This is a fun one. I like these because they're really not terribly hard, but you don't have a secant on your calculator. That's the problem, right? So secant of x equals negative 2.65. You're going to have to use your calculator, right? It tells you that, but I don't have a secant button. Okay. But what I do know is that secant goes with cosine. Okay. And so whenever I have cosine of some value, right, I take the reciprocal of that, and that's what secant is. Like if cosine, you know, on the back side, cosine was 5/3, that means secant is 3/5, or whatever, you know, they're just flipped with each other, right? Okay. So what I want to do is, what I can do here is I can change the secant to cosine, and I say cosine of x, but what is the flip of negative 2.65? Like, what is that flipped? Well, if you think about this as just being 2.65 over 1, which is kind of weird to think of a decimal and a fraction existing together at the same time, but that's okay. Negative 2.65 over 1, this would be 1 over negative 2.65, right? Cosine is just the flip of what secant is. So if I make that into a fraction, it's just going to be the flip of that, okay? So now, if I have cosine of x equals negative 1 over negative 2.65, I'm just going to take inverse cosine of that. Okay, and now I can find an answer. So x will be equal to inverse cosine. Oh, this pen is really bad. 1 over negative 2.65, and then I can plug that into my calculator. So that makes it really nice. X is going to be equal to, okay, and let's see. Mine is in degrees, but I probably want to be in radians, I'm guessing, because they're going to want the answer in radians. We can give both of them, I guess. Radians. So I'm going to do inverse cosine of 1 divided by negative 2.65. So in radians, that is going to be 1.96. I'm going to put radians afterward. 1.96 radians is going to be a little over 100 degrees. I'm going to switch it to degrees, calculate again. Yeah, x equals 112.2 degrees. Okay. Probably go ahead and leave your answer in radians, but there's both of them, so you just can kind of tell where that's going to be at. So there is that. Okay. All right. 18. Use factoring to solve 3 sine squared minus 8 sine x minus 3 equals 0. Okay. I'm going to switch these to just x's instead of sine of x's, and this is going to be a complex trinomial. Okay. So when we do this, we take 3 and negative 3, and we multiply those together to give us negative 9, okay? Now, what can we multiply to get negative 9, but when I add them, give me negative 8? That would be probably like negative 9 and 1, okay? And then I'm going to do this, 3x squared minus 9x plus 1x minus 3 equals 0, okay? I take that 8 and I split them into 2 pieces, okay? I'm kind of going through this fast, so if I feel like I'm going too fast, you know, kind of pause the video if you need to. I'm going to group and pull things out. So the first piece, what I can pull out of there is a 3x, and I'm left with x minus 3. And then out of the second piece, there's really nothing I can pull out, but you always have to pull something out, so I'm going to pull a 1 out, and I'm left with x minus 3. Okay, so here I have, oh geez, let's see, I have 3x plus 1 is one of my groupings, and x minus 3 is my other grouping. And setting those equal to 0. Okay, now, if I set this equal to 0, this will be x equals negative 1/3, because I'll subtract the 1 divided by 3. And this one, x will be equal to 3. Okay, but here's the deal. It wasn't x that I was solving for. I'm actually solving for sine of x. Okay, so I have sine of x equals negative 1/3, and sine of x equals 3. Okay, So what I'm trying to do is I'm trying to figure out what those two values are, okay? So I'm going to, this is the tricky one. This is a really tricky one. Okay, I'm going to go back to radians. Okay, I'm going to put my calculator in radians, and what I need to do is to find this first guy. I'm going to take inverse sine, and inverse sine. Okay, so x equals inverse sine of -1/3. And it is going to give me in radians negative 0.34, let's say. Negative 0.34. Okay, now, there is also another answer that my calculator is not giving me. Okay, and how do I find that other answer? Well, it goes back to that identity where we said that sine of x is going to be equal to sine of pi minus x. Okay, so what I can do is I just take pi and I subtract a negative 0.34 to get my other answer. So I'm going to take pi minus that answer, and that gives me 3.48 as my other answer for sine, plus 2 pi n plus 2 pi n. Okay, and that will give me the two answers that I have for sine of x is -1/3. That's where he's going to touch -1/3 at. Okay, now I'm about out of room, but if we do this one, if we do inverse sine of 3, he's going to say domain error. Why does he say domain error? Well, think about the graph of sine. The highest he goes is 1. Is he ever going to touch 3? No, not going to happen. So this one I'm not going to have any solutions for, so I will only have those two answers that I get from doing the -1/3. Okay? All right, so this is the kicker right here, is trying to remember that you have to take pi and subtract x to get that other value. Okay? All right, and the last one. Number 20. They give us some data, and this is based on data from 1971 to 2000. Okay? And they do averages for January through December and the precipitation. So they took data over that many years, 29 years, whatever that is, and put it in a table for us and took the average. Okay, so create a sinusoidal function to represent this data. All right, so I'm going to have a calculator do this for me. Okay, so what we need to do is I need to enter this data in. So I'm going to go on. I'm going to go stat, edit, okay, and then I have all of my numbers over here. I can't enter January through December in there like as words, so I convert them to numerical values, and the most logical way to do that is just to say January is 1, February is 2, etc., all the way down, so I need 12 of them. Then I go over to column 2, and I'm going to type in my precipitation, so 4.45. Give me just a second to do this. Or you might want to practice doing this also on yours so that you can click the right buttons. Okay, so if you need to pause, go for it. 1.17, I'm going to talk to myself, sorry. 0.38, 0.11, 0.03, 0.07, 0.2, 1.04, 2.49, and 2.89. Okay, I'm going to make sure that those are right. 2.89, 2.49, 1.04, 0.2, 0.07, 0.03, 0.11, 0.38, 1.17, 3.26, 4.1. Okay, so I've got all of them. All right, so we didn't have very much precipitation in June, July, August, September. And really May is kind of starting to decrease too. All right, so let's see. Do we want to graph this function? Sure. Let's go to our window. Okay, the smallest x value these are my x values. Smallest x value I have is 1. So let's start it at 0, just because I want to do that. And the largest x we have is 12, so let's go to 13. I usually put my window a little bit outside of what he is. Okay, my smallest precipitation was 0.03, I think. So let's just start with 0, and then the largest amount of precipitation I had was 4.45, so let's go to 5 on the y-axis, okay? So looking at these, I find the largest and the smallest, go a little bit outside of that. Let's graph. Nope, it's not going to graph. That's because it's not graphing. My stat plot's off. So go second y equals if you want to turn your plot on, and enter. Now my plot is on. Second quit, and I'm going to go graph again. There he is. Okay, so he kind of looks like a little curvy thing, which he should. He's going to be a sinusoidal function. So that curve is going to be a sine or a cosine, okay? And we don't have to decide if we're making the calculator do this for us, okay? We just simply go to stat, calc, and I go all the way down to sine regression. Okay, so I go down, it's like C down here in the list. Okay, I hit enter, and then it's asking me, do you want to use list 1 and list 2? Yep, those were the two columns that I used. So I'm going to go calculate, and it's going to spit out a sine function for me. Okay, so that sine function, y equals, okay, it'll be a sine bx minus c plus d, or whatever that is, right? That's what they say plus c. Okay. So this is the function, and then we're going to plug those numbers in for a, b, c, d. So y equals, my a value is 2.91, let's say. Sine of b is 0.40, x plus c, 1.81, and then plus d, which is 2.38. Okay, so this creates a sinusoidal function. That's my sinusoidal function. All right, there he is. Y equals that junk. Okay, use this function to estimate which month has an average precipitation of 2.25 inches. So we need to figure out where he is going to live, and we're going to plug him in for y. So I'm going to go ahead and do part B as well. 2.25 equals all that junk. Okay, you might not have to write this all out, but I always do. So plus 2.38. Okay, so now I'm going to unwind this equation. So I'm going to work backwards. I'm going to subtract the 2.38 to the other side first. It's going to give me a negative number. That's okay. All right, so 2.25 minus 2.38 is negative 0.13. Okay, all right, let's do one more thing before I rewrite all this. After I subtract that over, I'm going to divide the 2.91. I'm going to do that all at the same step. So I'm going to divide this guy by 2.91, and I actually get negative 0.045 equals. Okay, so that's gone. All right, so I'm going to try to do as many steps as I can at once. Sine of 0.40x plus 1.81. There he is. Okay, now I need to get rid of the sine next, so I'm going to do inverse sine. Inverse sine. Let me make him big again. Okay, inverse sine. So this 0.04, negative 0.045. I'm going to do inverse sine of that. Since he's already in my calculator, I can just do inverse sine of that answer. And I get negative 0. Really? Seriously, get that again? What? What? That is a weird thing. Let me. I'm gonna do that again. Let's see. I'm gonna type that in again. Inverse sine of negative 0.045. Yeah, that is right. Okay, equals 0.40x plus 1.81. Okay, so the last thing I'm going to do is solve for x. I'm going to subtract this 1.81. Okay, and that will be equal to 0.4x. So subtracting 1.81 will be negative 1.855, I believe, since they're both negatives. And then I would take that and divide by 0.40. Okay, so we're going to end up with a really wonky answer. That's kind of weird. Negative 1.855 divided by 0.4 is negative 4.6375. What in the heck is going on? What in the heck is going on? Well, X is supposed to represent time, like one of these months in here. But how can I have a negative month when my months only go 1 through 12? Okay, well, since my calculator will only spit out the answer that is in inverse sine, it's spitting out the negative number, okay? So what I need to do is I need to add the period onto the end of here to figure out where it is in my cycle of 12 months, okay? So the period for this function is 12 months. So I'm going to take that and I'm going to add 12 to that, which is going to give me month number 7.4. Okay, so what does that mean? Month 7.4. What's the 7th month? July. So I'm going to say mid-July is when we're going to have precipitation of 2.25 inches, which probably is not right. I'm going to use this function to estimate which month has an average precipitation. That is weird. That should not be right. Yes, July has way less than that. 2.25 inches. I don't know. Maybe our model is not a very good model, or the sinusoidal function that they spit out is not a very good model. Or we could have done something wrong with our algebra. But anyway, this is the right steps to go through that. That's kind of a wonky answer though. Maybe it's right. I don't know. Maybe this was just a fluke here. But that is how you solve and make yourself a sinusoidal function and then solve for a value based upon that. I wonder why that didn't come out nicer. Oh well. Oh, wait a second. I know why. Yeah, I know why. We don't add 12 months to it. We add 6 months to it. Or take, so since we're dealing with a sine function, this is why. Since we're dealing with a sine function, sine of x will be the same thing as sine of pi minus x. Pi because it's a half of a period. Okay, so in this case, a half of a period would be 6 months. So I need to take 6 months, which would be normally pi, and subtract what we got for our x. This is going to make it a little bit easier. So 6 months minus a negative 4.64. Let's do that instead. 6 minus a negative 4.64. And that will give me month 10.64, which is mid-October. Okay, so that seems a little bit more accurate. Mid-October would be somewhere in between there. And that October, like the beginning of October was 1.04, November was 2.49, 2.25 is going to live between those two. So I will agree with that, yes. Don't add 12, you don't add a full period onto that. The rule says that sine of x is the same thing as sine of half of a period minus that value, okay? All right, so there we go, not mid-July, not 7.4. There we go, it's actually 10.64. There you go, all right. If you have any more questions than that, and that did not answer all of your questions, feel free to message me, do whatever you need to.